Oh, hi, everyone. Hi there. I didn't see you there. You all snuck in right after the bell. Thank you for showing up for your learning, and thank you for arriving to review what are 2 units in grade 10. I think we're going to split this up into today and tomorrow, 2 days of review. That will give you more time to practice. Okay, so let's take a look. First, get out the calculator, your favorite calculator, your Excalibur-lator, and get ready to do a calculator check. We want to make sure that your calculator is set to degrees, not radians for our course, and not gradients as well. We don't want gradients, we don't want radians, we want degrees, yes. So check sine 45 and see, do you get the answer 0.707? If you don't, you and I need to chat about how to get it set into degrees. You didn't bring your calculator? Yeah, you can check at another point at a time. Cosine 120. This one happens to be negative 1/2, negative 0.5. Make sure you can get negative 0.5. How do I punch these, Mr. Jennings? Well, you punch them this way. Get your calculator out. My calculator here, I actually have to put in 235 and then push, give me the tangent of that, and it will tell me the tangent. Okay. Yours might be you push tangent and then put in the number. Just learn your calculator. But that's tangent for 235, so 1.43. And that's good for accuracy for right now. Okay. So make sure you can get these values. If you're not getting those values, you need to change the settings of your calculator so that it's inputting degrees. Okay. And if you don't know how to change the settings on your calculator, bring me over after the lesson and we'll figure it out together. We'll learn together. What are these acronyms? And should we go listen to a YouTube video to remind ourselves?
No.
Yes? Yeah? Yeah? Remind me, how is this one pronounced?
So.
Oh, so, yeah, okay. But how do I pronounce the S part? Sine. Does anyone, if you insist on calling it sin, then I'll look at you strange the whole unit. It's pronounced sine. Sine, because it's a short form. It's a short form for this word. It's not that much shortened, but it is shortened for sine. Okay. Sine is opposite over hypotenuse. And so that's like, it would be written this way. Sine x equals opposite over hypotenuse. Okay, so that's sine x. Cosine, well, that's the adjacent over hypotenuse. And tangent is opposite over adjacent. Yeah. Now, here is the typical right angle triangle. Of course, this little square notation there indicates to you that that's a square corner. That's a right angle corner. And how are you going to remember which one is the opposite, adjacent, and hypotenuse?
Hypotenuse is the longest side is opposite of the right angle.
Yeah, the hypotenuse is the longest one. It's always opposite the right angle. And I imagine a hippopotenuse. Okay, here's the hippopotenuse. There's its eyes. Here's its broccoli munching teeth. And it likes to lie on the riverbank, the hippopotenuse. And it's a very long creature, so it's always lying on the longest side, the hippopotenuse. There you go. And then, how do I distinguish the opposite from the adjacent?
It's like off your angle, so like whatever side your angle is opposite.
Yeah. JP, who are you sitting opposite? Alice, who are you sitting adjacent to? Ben, yeah. So you can think, if you live at like 55, then your adjacent houses would be 53 and 57, your next door neighbors. The opposite house is probably 54, unless you live on one of those weird streets where the addresses don't line up across the streets. Opposite, across the street from you. So because we call this the angle of interest, x. This is the angle of interest. That's just the one that we happen to be interested in, or the one that we measured, right? And then it's always opposite the opposite. So the opposite is across the triangle. Okay. Now let's go ahead and use our SOHCAHTOA to solve some of these problems. How will I solve for x? Find x. How do I do it? Well, in order to find x, I need to identify what trigonometric ratio is going to help me find x in that case. How do I know? Okay. So here is my angle of interest. Someone is telling me tangent. Why would I use tangent here, Caden? Oh, because I'm interested to find the opposite side, and I know the adjacent side, so great. I have tangent, which relates opposite and adjacent. Notice, no one cares about the hypotenuse in this problem. So cosine and sine both use hypotenuse, so we're not going to need them. We need the other one, tangent. So here's how we set these up. Tangent 67 is a known number. It's something that your calculator can tell you. So that's a known value. You can write it down. And it's going to be equal to the opposite over the adjacent. So you could write down your little formula there, opposite over adjacent, and then come down. Adjacent is known and opposite is not. So we can put those in. The opposite is x, and the adjacent is here, 14. So put that in. Yeah. And we know that that's going to equal tan 67 degrees. Then we get out our inverse operations pen. And if we're dividing x by 14, that's kind of annoying because x has a dance partner. We'd prefer it did not have a dance partner. So let's multiply both sides of the equation by 14. Before we go to our calculator, I would recommend you do that. That way, in your work, you will very clearly have this beautiful expression, 14 multiplied by tangent 67 degrees is exactly equal to x. There's the exact value of x. And then we can calculate it. So x is going to be equal to something. But here, this is an important step, and I want you to do this step all the time when you're doing trigonometry problems, and most of the time when you do any math problem. Guess first, before you go to your calculator. If that side's 14, what do you guess this side to be? Do you say 16? Okay, we got one guess. 15. You're shaking your head because you know better than that. What do you think? Big? You think it's in the 30s. Are you calculated already, or is that a guess? Yes, you calculated it already. Yeah, okay. All right. Yeah? You think 25? Cool. Jesse Pinkman says 25. All right. Yeah.
Jesse Pinkman? Buddy. What? Oh, wow.
You got a guess, Vaughn?
Go home and watch.
No? What do you guess here? 20-something. We're guessing X. Now, talk me into it. Why is it important to guess X first before you go ahead and calculate it? What math skill specifically? Yeah, your skill of estimation. You're going to be out there in the world without access to a calculator, and someone's going to say, about how high is that flagpole? And you can say, well, I can see it's about like 5 paces long, and the sun looks like it's making about a 60-degree angle. So I would say it's, about 8 high maybe. And then you would calculate it and find you're pretty right. So yeah, you're improving your guessing muscles, and if you do a chubby finger mistake on your calculator, you'll catch it if you get something way out of whack. Let's do the calculator method here. Notice that when I have this organized in my work, I just type 14 multiplied by the tangent of 67. So I can punch the whole thing in at one go. 33 is our answer. 33. There we go. X equals 33. Circle your final answer. Done. I rounded to the nearest one. No problem. How about this one? Find X. There it is. Okay, next problem. All right. Start with a guess. What's our guess in this case?
So it's going to be, you're looking for, oh my gosh. Wait, what? There's no, what angle of interest are you on?
This is the angle of interest here.
So you're going
30 degrees.
Like opposite adjacent as well. You're using tan.
Yeah, we're still using
I'm
tan.
gonna guess like 2.3.
So tan 30.
I'm gonna guess like 2.3.
Then tan 30. So that's like half.
This is 4 down here. This is 30 degrees. So do you think this is going to be longer or shorter than 4?
Shorter.
Leah's face changed when you said shorter. Why do you think it's longer than 4, Leah?
Wait, no, it's always longer than 4. But...
Yeah. It looks longer. Good.
It's gonna be 22.
Yeah.
Count me on this. 22. Watch this.
It's not going to be quite that long as 22.
I'm saying 22.
Here's I'm thinking it's longer than 4, shorter than 8.
Nah.
Yeah, it's got to be shorter than 8.
Right.
Look, if I take this and rotate it down,
I was just going off the left.
it's going to be there. And that'd be like 4, right? And then that'd be 4. And so I do a brief rotation of that in my mind, and I think that looks like a little less than 4. So I'm going to guess 7. I'll guess 7-ish. Okay, and I'm quite satisfied with my 7-ish guess. Okay, let's go. So people have told me this is still tangent. We still need tangent here because this is our angle of interest. We're not using the hypotenuse for this question. This is the adjacent side. This is the opposite side. So tan 30 is still going to be opposite over adjacent. But in this case, our unknown shows up on the bottom. And our known shows up on the top. Yeah, tan 30 degrees, just how it goes. So now, in order to isolate that, I have one extra inverse operation that I want to do.
Divided by x. No.
I'm going to multiply both sides by x.
By x.
I'm going to multiply by my unknown.
Yeah.
X over x is going to cancel. And so I've successfully isolated 4. Congratulations, me. I found out what 4 equals. Well, who cares? We didn't want to find out what 4 is. We want to find out what x is. So the annoying thing now is x is being multiplied by tan 30, and that's annoying.
Oh.
So how will I get rid of that tan 30?
Divide it, yeah.
I divide by tan 30 both sides. Good. Tan 30 is just a number. So I'm going to multiply by that number, divide by that number. Tan 30 both sides. Now, I'm going to cancel, and rewrite this so I have a very clean, exact expression for x. X is equal to 4 over tan 30. Oh, I teach this lesson in the morning. So I don't remember what it was because I'm not that interested in flexing on you math-wise. If I flex on you math-wise, it won't be that way. 4 divided by 30, but I take the tangent of it, equals 6.92. Oh, x is about equal to 6.9. X is really close to 7. Is equivalent by rounding. Okay, so there we go. That's how you do it. So I showed you these 2 examples. In both cases, we needed to do some thinking about like which ratio we needed. In both cases, it was tan. But sometimes your known is going to be on the top. Sometimes your known is going to be on the bottom. And you got a little bit more to do if your known is on the bottom. So those are some examples of those types of questions. Now here, in this video, I have the penguin behind me. It's beautiful. Okay, so now we want to find an unknown angle. We got, again, a bit more doing to do here. Yes, now in this case, we're going to be using some inverse functions, some inverse trigonometric functions to do that. What trigonometric function relates that side to that side? Sine, good. So we would say sine of theta. I don't know theta yet, but I do know it would be an angle which would have a sine of 14 opposite over hypotenuse 20. So now, how do I solve that for theta?
So you put it into inverse, and you put 14 divided by 20 inside the inverse.
Yeah, cool. So I do the sine inverse of both sides. That effectively isolates theta is going to be equal to sine inverse 7 over 10. I could punch 14 over 20, but it's the same thing as 7 over 10. So I'll just punch 7 over 10 to save my fingers. What? 14 over 20? Take out the extra factor 2.
Oh, no.
Yeah.
No.
It's the same thing.
Is it?
It's still going to work. Yeah. And so then that's my exact expression for theta. So we're going to go clear. And then first I do 7 over 10, which is 0.7. That's 7 over 10. And then I'm going to go trigonometry. I'm looking for my inverse sine function, and on your calculator, you probably also need to use shift or second function to find your inverse trigonometric functions. They might be written that way, or it might also be a sine. And then I push that, and it tells me 44. Oh no, we forgot the most important thing. Oh no. Guess. We forgot to guess. Yeah, I would guess about 44.4 degrees too. You know, I just kind of, yeah, it's about 44 degrees, and then we're satisfied, right?
63. Everyone put in
So theta is 44.4 degrees.
Today I had negative atoms in the chemistry question. I was like, there's no way.
Oh, antimatter, you discovered it. Congratulations.
It was horrible.
Nobel Prize in Physics.
I'm doing it. I'm like, negative atoms. I messed up hard.
If I have a word problem like this, what's my first step?
Make a triangle.
Draw a picture. I love it. Good. So I draw a building.
Also, if it's like, how tall is it? It's always going to be 90 degrees.
Yeah. And then when you're drawing a building, it's important to put a single window in there so people know it's a building.
No, that looks like a
and then I am standing 57 feet away. So let's put me here. Okay, there I am.
Oh, the angle of,
and here I am.
No.
There is my 55-degree angle. And I am 57 feet away. How tall is this building?
Pretty tall.
Well, here's going to be it's going to be pretty tall. Guess. So I need to know how tall I am in this question. How tall am I if I'm rounding to the nearest foot?
You don't need to know how tall you are.
6 feet. Where's the airplane? Good. That's the best Trig joke I've heard yet today.
Wait, what does that say?
He said, "Where's the airplane?"
Oh, I did say that. Yeah. What does that mean?
Well, because in so many trig problems, there's an airplane and we look up at it, right?
Wait, oh, you're looking for...
So, I am 6 feet tall. Thank you, Isaac, for that observation. Notice that my triangle here, my line of sight is parallel with the ground. So the building will be h plus 6 feet tall. A picture helps me understand that, right? My eyes are about 6 feet above the ground, or 5.5 feet would be my eyes, right? Well, let's round to 6 to humor me. Maybe I stand on my toes or I jump slightly to get my eyes 6 feet above the horizon. Okay, so that's there's my highly detailed diagram, and I can create a trigonomic ratio using tangent. Tan 55 is equal to opposite over adjacent. I know the adjacent side is 57. I'm looking for the opposite side here, height. So I have h over 57 feet is equal to tan 55. And then I multiply both sides. Guess for me. Guess. How tall will it be?
81.404.
Excellent guess.
87.
All y'all got to break your calculator addiction and start that mental math muscle. So I multiply both sides by 57. Cancels, and that will give me h. So what did you say? Did you say 81?
It's 81 and then like plus 6, so you got like
Okay, 87. Yeah, go. Yeah, I remember from the morning. I remember this one from the morning. All right, so this is 57 times tan 55, and your calculator will tell you that's 81 point something feet equals h. And then we put that into our diagram. Once your calculator outputs a number, it's up to you, the human, to interpret that number. That is how tall the building is above my eyes. My eyes are 6 feet tall because I'm like Fisher's height. So, Fisher, you're the tallest one in this class, right?
You're 6'4".
Yeah. So your eyes are probably exactly 6 feet off the horizon. So anyway, like way.
Go over to Fisher. Yeah. Go to Fisher right now.
Yeah. JP, you don't look as tall because you're you wear your height well. Okay, so then we add 81 into our diagram. Add it in here. This is 81 feet high. And then I see that 6 plus 81 is the building. So therefore, the building is 87 feet tall.
We've got the jumping shot.
Okay,
Sorry, it's just
cool. All right, and then for the rest, we'll do that tomorrow. That gives you time to practice some stuff. So what can I practice, Mr. Jennings, if I want to practice this? Well, let me take you on a tour.
We're gonna look at Ellis.
Yeah. Okay. I'll keep this in the video and I'll put this on the tour here. Let's go on a tour of our D2 well. We'll take a look at the D2 well. Here it comes. There it is. Okay. I hope trigonometry puns aren't a sin.
Sine.
I know a sin because that's a word in a sentence.
Oh, but it's pronounced incorrectly, so it's an anti-one.
Because I love them. Ah, it's a good one. Okay, so here's our schedule. I have an email. I'm gonna check that email in just a second. Okay. And I make this bigger. All right. So here we are today. I guess this is gonna come back here because it turns out I can't review both of these things in one period. So no problem, especially on the day when you get your report cards. So this will be switch shifting. Everything will shift down and we'll lose this buffer day. Okay, we'll lose this buffer day. I'll try and give you the practice test on December 5th instead. But here we go. For today, all of these things on page 220 are live. They're all skills that you want to have. Pythagorean theorem, grade 9. Understanding that the interior angles of a triangle add to 180. Those are actually grade 8 skills, both of them, right? Pythagorean theorem and interior angles of a triangle. Grade 8 skills? Yeah. Not to say they're grade 8 skills, so you should have known this already. Now, I'm happy to help you fill those gaps if you've forgotten those things. I know you don't remember these things. Maybe you do. Maybe your grade 8 teacher was better than I am at getting you to remember stuff. Probably was. No? Oh, okay. And then there is sine and cosine on page 220, but we're going to review that tomorrow, sine and cosine law. Okay, no problem. And those are also challenge problems. If you can prove sine and cosine law are true just using trig and Pythagorean theorem. This is very cool. And then there's also delta math. There are delta math things to practice too. So get reviewing, everyone. And then when's the test? We'll want to have the test on December 8th. That's when we're aiming the test.
It's not next Tuesday.
No assignment. No assignment in this unit. We want to speed up a little bit. Yeah. We definitely want an assignment at Unit 5. And we want to see if we can finish Unit 5 before Christmas break.
What's the fifth?
Yeah.
What's the final exam?
Trig functions is Unit 5.
Do we have the final exam?
Bye.